Howdy y'all, I'm Joe Hughes, and I'm here to give my presentation for GitHub Actions to automate multi-cloud deployments. This is all about taking your Terraform to the next level, right? So using Terraform to run infrastructure as code, this is actually elevating a little bit, even beyond just running inside of your environment. This is going to be about us using GitHub to be our source and also our CI/CD tool to actually go take all of these deployments and run them for us interactively while we're watching in this demo. So this is going to cover some GitHub 101 stuff. It's going to cover just a little bit of Terraform 101. This isn't really about the code itself. It's more about the workflow. It's about getting into understanding, branching, making sure that we're putting in a couple of pull requests, allowing this workflow to check our work and make sure that everything is validated correctly, and then actually doing our deployments itself. So with that, let's go ahead and get started. I've got a bit.ly code down here in the corner if anybody wants to follow along with this. This code will be a link to the repository itself, as well as additional resources for some Azure and AWS stuff. So a quick intro for myself, right? Who am I? Joe Hughes, currently a solutions architect at Veeam. I'm a co-leader for the Austin PowerShell and VMware user groups. Easily you can find me because I'm the guy typically with the green hat, the big grin, and the loud howdy y'all. And also, I have little shame and try and share my learning with others. Basically, I just try and make things a lot easier for everybody else. If anybody can learn from one of my bad mistakes or things that I did really incorrectly or something, then great, more power to them. It's all about sharing, and we just want everybody to contribute back to the V community here. So what is it we're really talking about in here, right? The primary two tools we're going to use with this are going to be GitHub Actions and Terraform, right? So for a quick overview of GitHub Actions, this is all about automating our code workflow, right? In the end, I'm leveraging this as CI/CD that we're not hosting, right? This is all being run out here. It can be triggered by events on these repositories. They can be extensible with your own actions. You can create your own code to run out here. I've seen some folks that have run some super fantastic PowerShell stuff for doing linting and all kinds of stuff like that. And one bonus point on this thing is you're probably already using GitHub, right? There's a good chance that all of us are getting into source code if you guys are not, master GitHub users already. And this is kind of the platform that just about everybody is standardized on. So it's a really good thing for everybody to get into and leverage this for also your CI/CD for the actual deployments itself. And then Terraform, right? It's a fantastic open source infrastructure as code tool. It's got to be good for Kyle Ruddy to go join the team along with Cody DeArkland. So things here are all written in HashiCorp configuration language. If you're new to this, be sure that you're using HCL v2. You just want the easier on-ramp for this. It's all fully JSON compatible. In the end, Terraform is about being declarative configurations, right? You want to declare what your environment should be, and Terraform will perform the magic to make it happen. As well as the fact that this also has providers for resource dependencies. That means that the providers themselves are not tied to the core Terraform code, so providers can be updated as there are changes that are required and needed without requiring upgrades to all of Terraform itself. So you can keep running on the same Terraform version and upgrade your providers, or you can keep your providers at the same version with Terraform core itself, upgrading to new versions as they release new features, and it won't break your code. You should still test it, but for the most part, things should not be breaking. And really how we're going to use this, right? We're going to use this to kind of stack a couple of tasks together. So we're going to be leveraging pull requests for this, just the way that I've got this workflow set up here. It's going to be going through and it's going to be doing an initialization and setup of the Terraform environment itself. It's going to do, our basic init to make sure that it's loading in our resource providers properly. It's going to go through and check our formatting on the files themselves. It's going to go through and do a validation of our plans, and then it's going to actually run the Terraform plan to make sure that everything looks good for itself and shows us all the changes that are required. So we're going to be testing that by using branches, right? And those pull requests are going to go through all of the steps. Only when we push back to made, which we're going to do by merging the pull request back in, is it going to actually run the apply step. And then down at the bottom, I show that I'm actually going to have a workflow that I will show for everybody that is a manual destroy, right? There's no automatic anything that I have in here for this. It is a push button. First of all, nobody wants to push the button. But second of all, I just want to make sure that somebody doesn't accidentally run something incorrectly and manually destroy an environment, automatically destroy an environment. I want it to be a manual interaction where somebody has to push a button. So for this instance, like task 1, task 2, task 3 here, in our demo, task 1 is going to be deploying an SDDC. So we're going to create a full SDDC within VMware Cloud and AWS. Task number 2, we're going to apply some NSXT rules so we get access to the environment. Task number 3, we're going to actually clone a VM. And that's what we're doing here. So other components that are used inside of this demo, one is going to be GitHub secrets. This is just secrets that are added to the repository itself. So this is going to cover our API tokens and our org IDs for API tokens for Terraform Cloud and for VMware Cloud on AWS, and then our Amazon account number for AWS, and then it's going to also have our org ID for VMware Cloud on AWS, right? All these secrets I will cover in the demo, so don't worry if you didn't catch those names right now. And then Terraform Cloud, right? We're using this to be just the remote backend for Terraform State only, which means we have that execution mode on our workspace in Terraform Cloud set to local. Don't worry, we present this stuff in the demo. And then other tools, again, just to be explicit about what's used in the demo. I'm running some VS Code. I've got Terraform locally on the box for doing some testing and doing some fixes to be able to push these files back up. And then we're even running through a couple of deployments through just the GitHub GUI and manually uploading files and putting in some commits. So nothing too terribly intense here. And then the magic you get from some of this stuff, right? These are just a couple of screenshots that I have from a notification on my phone, and then on the left side, and then on the right side, the actual update that I see when I go into the Terraform app from my phone. I also use Pushbullet, so I have these notifications mirrored to my desktop. So if I have a plan that gets to the point of succeeding, and I get all the output from, you know, format and styling and the init and the validation and all that stuff, it actually pops up on my phone. So I can put some of these things in place in a workflow, get out of GitHub, sometimes get up and go get some coffee or something, and you know, typically a few minutes later I should get a notification that says, hey, look at this, everything was good, you know, you're ready to go ahead and commit these changes and let it apply things to the environment. So it's some great stuff. You don't necessarily have to be directly tied all to, you know, GitHub Actions in GitHub and stare at it all the time. You can walk away, and there's some great things you can do with bots and a little bit of code. So with that, let's go ahead and move into demo number 1. Okay, everyone, we're going to go ahead and get started into our demos here. So the first thing we're going to take a look at is we actually have an existing SDDC. So we're really going to kind of run through this demo twice, right? We're going to see the deployment one time, then we're going to do a little bit of, you know, TV magic of swapping the new cake with the pre-baked cake, just because it takes us about 90 minutes in my past runs to get an SDDC deployed. So I've got one that's already up and running. It's a single node SDDC. So what we're going to do with the next run of this is we're going to actually change and drop that type of the one node. We're going to deploy a 2-node SDDC. That's just a limitation of VMware Cloud and AWS, right? We can only have one single node SDDC running within our account. So we're going to go ahead and redeploy a new one with a new name as well. So if we take a look at our GitHub repository where all of this code is going to run from, as you can see, we don't really have much here right now, right? I've got a license, I've got a README file, and then we have our workflows. So we'll go ahead and look in our workflows before we dig into the secrets that we've got on the back end here. So the workflows that we have, this one is the only one that runs with automation, right? It's titled Automated Terraform. That's just what's going to show up when we actually look at our GitHub Actions tab and see the workflow runs. So this is set to run on a push action on our main branch and on pull requests, right? Any pull request for any branch. I set this up this way just because of the fact that we can actually do some branching in our local client. We can push the files up and commit them on a new branch, let the workflow action run against a pull request once we create it, and let it run through all the steps that we want it to do. So this Terraform job, right, is going to run on the Ubuntu latest GitHub Actions runner. So this is going to be the hosted runner that lives out in the cloud. By default, it's going to run the bash shell. And the steps that it's going to run, right, this is really all of the actual power that runs behind this thing. The first thing it's going to do is check out our repository to the GitHub Actions runner. We're going to run through the HashiCorp / setup Terraform action. So this pre-formatted GitHub action out there, the only thing we're going to feed to it is our credential for our Terraform Cloud API token. We'll run through creating a new organization and getting this loaded up in here essentially kind of from scratch. And then once this has the newest version of Terraform CLI installed on this and configured to connect to our Terraform Cloud backend for the remote state storage, then it's going to run through a Terraform init. This text that I have here that's commented out is just to show that we actually have the ability at every step to give back the outputs of steps that ran prior. So if you want to get these standard error exit codes from your init statements even, you can get all that stuff back, right? It's just to show that there's additional things you can do inside of here. You're not just limited to what's already here. I run a Terraform format. I just do this to make sure our config files are in canonical format. It's basically one of the easiest ways to verify, especially with all these IAC files living in GitHub, just to make sure that the diffs are fairly easy to read. Make sure that everything is going in a standardized format. It then runs a Terraform validate just to make sure that our plans are good within all of our config files. Then it will actually run the Terraform plan itself. We are feeding it variables for our VMware Cloud on AWS API token, our org ID, and the AWS account number, just so that I can pull back our subnets within the VPC. If all of these steps run successfully, the next step that's in here is to write the output for our pull request. So this only runs if the GitHub event is a pull request, but what it will do is it will give us back all of our prior outputs from before, right? It gives us the outcome of the formatting step, the initialization, the validation, and the plan, a couple of random little emojis in here. This is what gives back that nice little notification that I showed earlier. That was the pop-up that came in through my GitHub app on my phone. And I actually have that mirrored to my desktop just because of the fact that I'm running Pushbullet, so I get that notification even as a pop-up on my desktop, which is nice that I can run a pull request in GitHub, not even have to open it to watch, and I will just get, essentially within a couple of minutes, if everything worked properly, I'll get a notification that like the plan succeeded. If not, then I obviously know I need to go back and double check that. And then the last step that's inside of here is if we are pushing to our main branch, then we will actually go run the apply, right? We already know that we were able to initialize, we were able to verify that the formatting was correct on these files. We did the validate and we did the plan steps, and all of those succeeded for us to get to this point. And at this point, I'm going ahead and doing an auto approve. Again, same thing, feeding in our variables for our API token, the org ID, and the AWS account number. So all of these are here inside of secrets. So we will go ahead and take a second to take a look at these secrets and see what we have inside of here. So again, for these secrets, it's my AWS account number, my Terraform Cloud API token, my VMware Cloud on AWS API token, and the VMware Cloud org ID. This is all just inside of here because this way I can manage it within the GitHub repo. So this can be all settings that are specific to a specific deployment that you're doing and managing. Again, you're not putting API tokens, you're not putting secure credentials into any of your config files. This is all living in the repo level. Only anybody who has, owner access to your repo would be able to get in and update these or see these. They're not going to come across when somebody, clones your repos or anything like that. Anybody with collaborator access on the repo can use them in a workflow, but that's the most lenient access that's there. They wouldn't be able to actually get back what these secrets are, only to put them into a workflow and run them. So I'm setting all of these inside of here just to keep these within secrets. It's easy for us to parse and put them back into the workflow. The next workflow that we have is a manual destroy. This I have set up to run only on a workflow dispatch. This means you actually have to go into the workflows, you have to click the settings menu, and you actually have to tell it, go run this manually, essentially, right? Because this is doing a destroy, I don't want to run this from any particular action within our workflow itself. I want this to be an intentional action somebody has to go do. And it's essentially the same steps, right? It runs on the Ubuntu latest GitHub Actions runner. In the bash shell, it'll go check out our repository. It'll do the Terraform setup and connect to our Terraform Cloud backend just to pull back that remote state storage. And then it will run the init, the validate, and then it will do a destroy of this environment. So that's just a quick, push button delete of everything if we get to a point where we need to undo what's in our code and what's in our deployment here. So looking at this again, we have nothing inside of here, so we're going to kind of do this interaction from scratch. So one of the first things I'm going to go ahead and do is I'm going to flip over to Terraform Cloud. I'm going to go ahead and create a new organization. So I'm going to call this one Live Demo. Use my email address on this thing. I'm going to create a new workspace. We're running this as a version control workflow, so we're going to connect it back to our version control provider. In this instance, it's going to be GitHub. So I'm going to go connect to my Terraform-VMC-deploy workspace, create a workspace with the same name, and I'll go ahead and copy that name. I'm going to do, actually, I can just paste this thing easily enough. Come on. Sorry, apparently Notepad does not want to agree with me today. No, I don't want to download an update. Sorry, y'all. Apparently Joe did not do enough demo prep for this. No updates. The next thing we're going to want to do with our new workspace here in the Terraform Cloud is if we're only going to use this for remote state for the backend, you want to go to your general settings and change this execution mode to local. This means that the plans and applies occur totally on the machines that are outside of Terraform Cloud. We're not actually running this here. We're running this through GitHub Actions and through that backend. So now that we have this saved with, with a local execution mode, we can go back to our repository, and I'm going to go ahead and actually flip into it on disk. So I'm going to show, again, got our repository, essentially have nothing inside of it. I'm going to open this up with Explorer, and we're going to start with the easy method of actually getting our stuff up here. So for everybody who's not super proficient in GitHub, right, I'm just going to go ahead and start this as I'm copying over files, right? So I'm taking my good working files. I'm going to go ahead and open these up in VS Code, and we can start making some tweaks. So I have this open, and we want to go ahead and open our main TF, our variables TF, and our TF auto vars. So one of the first things I'm going to go ahead and do here is I'm going to change my organization to live demo. This is for, again, our Terraform backend. I'm going to copy and paste our new workspace name to get this inside of here. And then one of the next things I'm going to do here is we're going to comment out our line item for our SDDC type of one node, because this one's going to actually be a multi-node SDDC environment. So save this file and close it. And then the next thing we're going to do here is update our number of hosts inside of here. And I guess just to clarify, I'm going to walk everybody through this a little bit, not to be a dump on Terraform itself or anything, but all we're doing here is for Terraform initialization, right? We're telling it it's going to be a remote backend, which will automatically link to Terraform Cloud. I give it an organization ID or name and a workspace name. We're going to say we're using this VMware Cloud provider, right? This VMC provider, giving it our API token, our org ID, give it the AWS account number that it's going to be connecting to on the AWS side to pull back details of our subnets that are there. And then we're giving it some basic details for our SDDC that we're going to deploy, right? A name, the sitter from our VPC, number of hosts, the provider type, which is going to be AWS, so it's just hard-coded in here, the region that we're coming back from, our VXLAN subnet, and then, some false variables for things we're disabling here. It's going to be single availability zone deployment type, and then I've got some subnet IDs, account IDs, and then timeouts that are in here generally. And then we're giving it a VMC public IP address for the NSXT reverse proxy URL that we're going to use later on. And again, all these things are just defined here in the variables. And then this TF auto vars that we have, we're just giving it, a name, number of hosts, the region, the sitter, the subnet for VXLAN, and then a display name for our public IP address. So we can go ahead and close out these files, and we're going to get these up to GitHub. So we're going to do git add all. Actually, we're going to branch first. We're going to check out a new branch, create new SDDC. Okay. Now we're going to add all of our files inside of here. And again, if you guys are not super proficient on the Git side of stuff, I'm not super proficient on it either. So some of this we're going to cover through the GitHub UI in a bit. So I want to go ahead and add a commit message on this one of creating our SDDC. Create new SDDC. So I'm pushing our branch back up to GitHub. Once we see these uploads starting to take place, we will go ahead and flip back to our GitHub repository. And in a second here, we will see we've had a new branch that has recent pushes less than a minute ago. So we're going to compare and check out this pull request. I'm going to go ahead and create the pull request for it so we can watch our workflow start running here. Okay, so we'll look at the details of these checks that are running. So again, we've got the name of our workflow, this automated Terraform. We have the name of the job, which is automated Terraform job, that's inside of here, and we're running through these steps, right? The checkout worked, the setup Terraform worked, and Terraform init had some problems here, right? So it's telling us here that it's finding the latest version of HashiCorp/VMC, and it failed to provide it, but it found a possible alternative of Terraform-providers/VMC. So it looks like this is the case that we know of. At the beginning of September, there was a change with the provider for VMC, and it got retitled. So it's telling us if all of this looks okay, we can simplify this thing by just going ahead and running this Terraform upgrade. So we're going to go back to the command line. I'm going to clear my screen. I'm going to go ahead and run this upgrade and see what happens here. Okay, so it says that ran. I'm going to run git status to see what's different. So we have a versions.tf file. So now if I go back into VS Code and take a look at this versions.tf, this is just specifying that for the provider named VMC, we give it an explicit source of this Terraform-providers/VMC. So great, we're fine with that. This should all work now. So we go ahead and add all the files again. Git commit, we're adding versions.tf. Okay, we're going to git push origin, create new SDDC. So we're just pushing our branch back upstream. We will see a new commit on this. So now this branch has another commit. We're going to go back to our workflow yet again and go look at it. So the next version of our workflow that we've got here is going to run, and we should make it past the init stage. Okay, so checkout was successful, setup Terraform was successful, init was successful. Now we ran into problems with formatting. So based on the output that I have that's displaying here, set up in our workflow, it just gives me back, essentially what was the status from this format. So it doesn't like my formatting because I needed additional spaces inside of here. So I'm good with that. So the easiest thing for us to do is go ahead and take a look at this at the command line yet again. So clear our console. But just to check it again real quick, I'm going to run Terraform format check. So it didn't like my auto.tf vars, and it also did not like my main TF file. So if I go check these again, yeah, it's just putting in a bunch of extra white space here. That's all it's doing on all of these line items. It's spacing everything out properly into the canonical format. So I'm perfectly fine with all of this. So I'm going to go ahead and run my Terraform format command and add everything again. Updated formatting. Okay, so all of these commit messages are coming in here to show what it is that I'm actually doing on the command line here, and then what it is that's going to happen within the workflow itself, right? So we'll see every checkpoint that we had essentially for every one of these commits, and in the workflows we'll be able to see like where these succeeded or failed. So updated formatted. So this is going through yet again. So we're going to take one last look at our workflow here, waiting for this thing to initialize. Okay, so the checkout is good, the setup is good, the init is good, our format is good, validate is good, plan should succeed. Okay, writing out. So yeah, post checkout, everything is good, completed the job itself. So if I go back to the pull request itself, which I can just go ahead and close and get back to here, you'll see again, this is the output that comes back from this, right? The only thing that I'm explicitly putting all of the details back inside of here are just to show us like the plan of all of this, right? What is it going to do? It's going to go ahead and deploy us a new SDDC that's here. I like all of this. We're going to put in a note of Joe finally got it right. Add a comment. Merge our pull request. Confirm the merge. Okay. So now, if we do the other view for this, right, we can go back to our Actions tab, and we can see within our workflows, we only want to see this automated Terraform workflow because this is the only one we're actually letting run without a manual button push. And I can go look at the status of this run from my merged pull request. So if I come into this job here, we will actually see we've got the setup worked, the checkup worked, the setup of Terraform itself worked, the init, the format, the validate, and the plan. And the plan will show us here that it's going to deploy us a new SDDC. We can see that the apply is running here. So if I now go back and look at my SDDCs within VMware Cloud and AWS, we should see that there is a second one that is deploying for us inside of here. I'm waiting for it to show. 30 seconds elapsed. Okay. Okay, and as we can see here, we now have a new SDDC that is deploying. Unfortunately, I goofed and totally forgot to change the name of this, but we can see there is a new ESXi host deploying here, and at this point it's telling us it's essentially almost 2 hours for this thing to get deployed. So this is at least up and running. We're going to go ahead and switch from this to the other GitHub repo that we have available to us for this. Okay, we've completed demo number 1, and we're going to go ahead and jump into demo number 2. Okay, we're back for demo number 2, and this demo is essentially gonna just take off from where we ended the first one. So at this point, we actually have an SDDC that's been created. So through the second GitHub repository, we're working on my existing SDDC that's up here, my single node instance. So if I look at the details of this thing here, I have already created a manual rule to allow access to vCenter for me to get in just to do a quick deployment of a template up here, and then have since gone and set everything back. So if we come in and look at our gateway firewall and look at the management gateway, we currently have no rules that allow access to vCenter other than our outbound rule, right? So we have no inbound access to vCenter. What we're going to do is we're going to go ahead and create, upload some files into here that are going to create our new NSXT rules. So for this demo, we're actually just going to work a little bit interactively here at the GitHub UI. So again, for folks that are not super proficient at doing all this stuff at the command line, it's not a big deal. I've created a new branch. So what I want to do now is I want to go ahead and add some files. I'm going to go upload files. I'm going to add my NSXT rules files. I'm going to create a commit message of the same and go ahead and commit these changes to our new branch. So once these files get uploaded into this new branch, we're going to see that we have the ability to go ahead and create a new pull request. So this branch is now one commit ahead of the main. So we're going to go ahead and do a pull request. I'm good with that commit message. So we're going to go ahead and fire this off so we can take a look at the workflow. So one thing I want to show is, the most current state that we have here in Terraform Cloud is as of an hour ago. So I'm going to go ahead and let this workflow run, and then we'll jump back in and we'll take a look at the states once this thing has validated and planned. And if we can complete this merge request and go ahead and get it to apply, then we'll go ahead and see what happens afterwards. So far, everything looks good, right? Setup's good, init's good, format's good, validate's good. The plan is coming through here and telling us, I've got what I need, and it skipped the apply because, again, this is just the dry run through. So now that this is good on our pull request, we can see everything validated correctly. And I can put in a commit message of, huzzah, it's right. Go ahead and add a comment. I will merge in our pull request. And we will take one last look at our actions afterwards, just to go ahead and let this run. And we'll take a look and see what happens. So at this point, this should come through and apply, and really in the end, all it's going to be doing is it's going to be creating some rules to allow all from the internet to get to vCenter on HTTPS and to allow access to ESXi for the VMware Remote Console service. So the plan is running right now. Apply is running currently. This should go pretty quickly, just so we can see what happens here. Yep, one changed, one destroyed. Okay, so minor changes, mostly because things might get out of order on this. So if I come in and refresh and take a look at my workspace and my state file, the last change should be, as of a couple seconds ago, right? So our state file has now been put back into Terraform Cloud because we've actually run an apply on this. So we've got a valid state that got set onto onto Terraform Cloud. So now if we come back in and look at our gateway firewall yet again and refresh for our management gateway, let's go ahead and refresh this screen. Okay, so for management gateway, we are now allowing access in from any source to vCenter for HTTPS and allowing in from any source to ESXi for provisioning and remote console. So now I can go ahead and open up vCenter. Go ahead and copy my credentials just in case I need these and they're not cached. Okay, good. We are into vCenter now. And essentially this is a clean instance, right? All I've done is come in here and I've uploaded it a single ISO to be able to run a Packer build for an Ubuntu template that's inside of here. So we have a single ISO file that's in here. I have a single VM that lives outside of our resource pools and just lives under the workloads folder. So this Ubuntu-template is what we're working with here. So now if we come back to our GitHub repository, we're going to create one new branch, and we're going to create a branch named create-vm. So I'm going to create this branch. I'm going to come and upload a couple more files. So I'm going to upload my files for my new VM. And all I'm doing here is essentially just targeting, one second, adding files to clone a VM. All I'm doing in here is adding a couple of files that we can go ahead and take a look at inside of VS Code. So let me get these fired up, and now that we have a commit on this branch, we can start our pull request, and I will let this workflow go ahead and start running our plan while we look at the files. So for variables here, all we're doing is defining the data center, the cluster, the workload data store, and the compute pool that we're putting this into. This is all running with variables for the defaults, right? It's our SDDC-data center, cluster 1, workload cluster, compute resource pool. These are all the defaults that just come in out of the box from VMware Cloud and AWS, because again, this is just supposed to be a simple demo. And then all we're doing here is we're pulling in username and password that comes in from our SDDC instance that we already have in the state file. We're trimming out the details for our vSphere server that we're trying to get into. We're just doing some string manipulation from the object to remove HTTPS and the ending slash that comes back from our URL. And in the end, I'm looking for a VM template that's titled Ubuntu-template, and I'm going to create a new VM that's going to be titled Terraform-test VM. That's really all we're doing here, right? We're cloning a VM that already exists within vCenter. So all of our checks have passed. So real quickly, let's go ahead and go into our actions. I just want to take a look to see what it shows us that we're going to be doing. So for adding files to a clone VM, we can just go ahead and skip down to our Terraform plan and see what it shows us that we're going to be doing. So we're going to be creating, again, a new VM, and it's going to be titled, if I can find it inside of here, Terraform-test VM. So the plan succeeded. Let's go ahead and come back to our merge pull request. We're going to go ahead and tell it, make that VM. Add a comment, merge our pull request. And as soon as this workflow runs successfully, let's come back in and watch the workflow. Once this is done, we should have a new VM that exists in here inside of our vCenter to just show us that we have created a cloned VM that's just titled, again, Terraform-test VM from the Ubuntu-template VM that exists here. So this is running now, it's planning. Once it starts the apply, we can go ahead and flip back in here and we may see some things happening on the fly. Planning. Okay, the apply is running. So under here, if we come under our compute resource pool, we should soon see that we are creating a VM. Yep, so here's our new Terraform-test VM. We can see that it's cloned the virtual machine from Ubuntu-template, and it is now powering on our Terraform-test VM. So we've created a new VM inside of a defined resource pool. If we look inside of here, right, it just defaults to the workloads folder, but this is all coming directly from Terraform, just cloning this thing out for us. I want to say one of my tests have run in the past. This was 30 to 40 seconds for this thing to run all the way through the apply. So we should see this complete pretty quickly here. And this is, the last of our demo, right? We're just showing that at this point we've created an SDDC from scratch. We have gone and applied some NSXT rules for the firewall on this just to give us access for vCenter and for the remote gateway. This is now complete. It looks like this time around it took us 54 seconds to apply and create the VM. But we have this thing up and running, right? Here's a new VM that's been cloned from an existing instance that we had here, and everything is working. So again, we've created an SDDC, created some NSXT rules and applied them. We have cloned a VM that exists inside of this environment. And this just gives us an idea of the things that can be done with Terraform and with GitHub Actions. Again, this is all about just taking your existing Terraform code and kind of taking it to a whole new level. The runners being ephemeral instances, right? All of your code has to be totally self-contained. You have to properly define your variables. You can input things from secrets to make sure that you are properly accounting for passwords and API tokens and not keeping them directly in your config files that are open and available for anybody to see on GitHub. But, these ephemeral instances spin up. Your code is always deployed exactly the same way. You can see what happens when you run the setup, that your formatting is correct, that it validates, that it checks the plan against the existing instances. It keeps this remote state in Terraform Cloud, right? If we go back and take a look at Terraform Cloud again, we can see that we've got, yet another run that's going to show us a few seconds ago here, sorry, a minute ago, triggered from Terraform. We can download these state files directly from Terraform Cloud and take a look at these, or you can actually use these to run interactively through Terraform to take a look and investigate these state files by just downloading these. So all in all, this is a quick, simple overview. There are other links if y'all refer back to the slides, and I'll throw up an ending slide after this, that have some examples for going and creating resources in Azure and AWS. Again, just remember, this is Terraform, it's accessing APIs. You're definitely going to want to, verify that you have access to everything and are properly formatting all of your links if you're trying to get to things that are back inside of your environment as opposed to just being public cloud. But hopefully this demo helps you guys out. This is a pretty good run through of what Terraform can do, and especially with GitHub Actions. You have the ability to run Terraform, you can run PowerShell code, you can run Python. You can, essentially kind of think of this to be even a replacement for things that you're currently running as like functions as a service, right? It's a little bit easier to keep these things inside of this repository, keep them under source control, and run them as you need to, or have the ability to run them automatically or run them through triggering manually with a push button like we have for our destroy. So thank you all for checking this out. I hope this demo really helped everybody. Okay, everybody, just a quick wrap up and closing, just to make sure everybody's got the link. Thank you all for coming. Thank everybody at VMware for allowing us to present for VMware Code Connect 2020, and see you all next time.